Alright, this is a video reminder of how to reduce block diagrams. Essentially, this is just a table from Dorff and Bishop Modern Control Systems 12th edition, table 2.6, to give credit to them. Alright, what I want to remind you is if blocks are in cascade, their gains are multiplied together or their transfer functions are multiplied together. Alright, so you can kind of see that from rule number 1. Rule number 2, if we want to move a summing point, we can do so, but we need to make sure that we account for it when we do so, so we follow rule number 2. If we want to move a pickoff point, again, we can move this pickoff point over here to the other side of G, but what we need to do is account for the fact that G is not there. The reason I can say that is if I look in particular at x1, then x2 is equal to gx1, which means it's gx1 down here. And if I have moved this pickoff point, then I have x1 here, and this looks like gx1 also. So I need to make sure that g appears. Otherwise, it would just look like x1. All right, same thing goes for number 4, which is moving a pickoff point behind a block. Essentially, if I look at this, x2 is equal to gx1. All right, if I move this pickoff point, I want x1, but I know that here I have gx1, but I want x1 out of here, so I need to divide by g, so that way I do in fact have x1. All right, there's also a way to move a summing point ahead of a block. All right, we can follow that rule here. It's actually pretty straightforward. And then lastly is eliminating a feedback loop. Remember that in general, we assume that this looks like a minus sign here, which means that in general, this denominator is going to be 1 plus GH. All right, sometimes that's not true, but typically we look for negative feedback.